Hello and welcome to another maths lesson. Yesterday we were looking at the bar model and how we can use that to help us solve problems. Today we're going to be looking at another type of representation, the part-whole model. And we're going to be looking at some problems that you can use it with and how you can just use it generally to help you think about your calculations and help you represent number. So let's get going with a flashback 4 to warm up and then we'll talk about part-whole models. Here's today's flashback 4. Have a go, click pause, and click play when you're done. Let's go through these answers then. Question 1. Divide 15 by 5. 15 divided by 5 is 3. Question 2. There are 10 crayons in each pack. How many crayons altogether? Well, the easiest way to do this is just to count in tens. 10, 20, 30. There are 30 crayons altogether. And question 3, complete the sequence. 16, 14, 12. It's counting backwards in twos, so the next two numbers are 10 and 8. And finally, question 4, find the sum of 9, 5 and 1. That means how many altogether. That's what sum means. So we need to add 9, 5 and 1, and the answer is 15. Okay, let's have a look at our main learning for today. Okay, today we're having a look at part-whole models. We're going to start off talking about how you can use them to represent numbers, and then we're going to explore some problems where you might want to use a part-whole model to help you. So let's just think about part-whole models to start with. You can see here that I've got a part-whole model with two parts, 6 and 4, and the whole, 10. Now notice that these are the same part-whole model. They've just been rotated around. And in each one, 10 is still the whole and 6 and 4 are the parts. So make sure when you're looking at a part-whole model, you think really carefully about which circle is the whole and which are the parts. You need to be thinking about which circle has got all of the parts connected to it, and that's 10. And it doesn't matter whether it's at the bottom, at the top, or at the side, you can see it's got all the parts connected to it. Let's have a think about some calculations then that this part-whole model can show. 6 and 4 make 10, 4 add 6 makes 10, or they can represent subtractions. 10 take away 6 equals 4, or 10 take away 4 equals 6. Now, especially when I'm doing subtractions, I like to really imagine that one of the parts is actually being taken away. So let me show you an example of that. I could here be doing 10 take away 6 equals 4. And what I've actually done is I've covered it up as if I've taken it away, and that straight away lets me see 10 take away the 6 gives me the 4. And that's just a really helpful way of thinking about a subtraction calculation when you've got a part-whole model. Let's have a look at some examples then to see how we can use part-whole models to help us think about mathematical problems. So one of the types of problem that's really helpful to use a part-whole model for is a missing number problem, where we've got a number in the middle of our calculation that's missing and we need to find out what it is. Normally we're used to the missing number being on this side of the equal sign, but it's not always there, and this is where a part-whole model can come in quite handy. So let's have a look at what we've got here. 38 add something equals 45. Now by putting these numbers into a part-whole model, we can really see what's happening and we can work out what we need to do to help us work out this missing number. So 45 is my whole. That's what I have altogether, my biggest number. And my two parts are 38 and something. 38 add something equals 45. Now that I've written this as a part-whole, I can see that actually I can work out what the missing part is by doing 45 take away 38, and that will give me my answer. And in this case, the answer would have been 7. And I could go on and check that by doing 38 add 7 equals 45. Let's have a look at another missing number example. This time we've got a subtraction, and I've got something take away 19 equals 25. Now we have to be a bit careful here because we have to really think about what's going on, and this is where we can come back to our part-whole model and think about how it works with additions and subtractions. Something take away a part, and that part is 19, gives us another part, 25. So if we fill in our part-whole model, it looks like this. something, take away 19, so we could get rid of that 19 and we'd be left with 25. Well, now this quite tricky problem all of a sudden makes a little bit more sense, because we now think to ourselves, well, we could do 19 add 25 and I would find out what that whole is. So this slightly tricky subtraction question becomes quite a straightforward addition question. And putting the numbers into a part-whole model and thinking about which bits are the parts and where is the whole can just help us think through the problem and turn a tricky problem into something a bit more straightforward. So let's have a think about one more example, this time using money. Pavitt has these coins in his wallet. He buys something for £1 and 20 pence. What coins does he use? Now, I've drawn a part-whole model here to help me break up the number. £1 and 20 pence. For me, it's helpful to think about that as 100p, that's 100 pence, and that's the same as £1, and 20 pence. And you can see here I've got two 50p's, a £2 coin, a 2 pence, and a 20 pence. And I need to think about how I can make £1 20. Now I actually drew a second part-whole model. I'd taken my first part-whole model and I had a 100p and 20p. Now I know that I can use a 20p because Pavitt had that in his wallet, but we didn't have a £1 coin and we certainly don't have a 100 pence coin because they don't exist. So I thought to myself, well, I need to partition 100 pence even further. And I saw that I had two 50p's, and I know that two 50p's makes 100. So here I worked out that I had 50p, 50p and 20p, and they could work together to make £1 20. So by partitioning one of my parts up even further, it allowed me to work out the question. Okay, time for you to have a go at some problems now. So we'll do exactly the same as we did yesterday. I'll put up the problem, read it through, and then you can have a go, and then we'll check it. So first question. Rosie is making 70p in different ways. Draw 3 part-whole models to show the coins Rosie can use. And then part B, can you make 70p in any other ways? Before you have a go at this, just one thing to remind you. When we're talking about using coins, we need to make sure that the numbers we're using are actual coins. For example, we can't use a 3p coin because a 3p coin doesn't exist. We also can't use a 25p coin because a 25p coin doesn't exist. So you need to use coins that actually exist when you're thinking about your parts. So have a go at making 70p in different ways, see if you can draw 3 and then work out whether there's any others. Click pause here and have a go. Okay, let's have a think about how you could have answered this question. Now, your part-whole models might not be exactly the same as mine, so if you do need to get an adult to check them, that's absolutely fine, but I'll give you some examples of the sorts of thing you could have done. So the most simple one is probably this one over here on the left. 70p is made up of a 50p and a 20p, just 2 parts. Over here, I have drawn a part-whole model with more than 2 parts. I've drawn it with 3 parts. And you can see that it's very similar to this one. I've just split that 20p up into 2 10p's. So 70p is made up of 50p, 10p and 10p. And you don't have to limit your part-whole models to just 3 parts. Have a look at this one I've drawn. It looks a little bit crazy, but it still works. 70p is made up of 10, 20, 30, 40, 50, 60, 70. 7 10p coins. And there are actually loads of ways that you can make 70p with coins. You can keep going all the way down to 71p coins, which you probably wouldn't be able to draw, but is an interesting way that you could make 70p. So there's loads and loads of ways you could have done it. And like I say, if you need an adult to check that your ways are correct, then you can pause here and go and do that. Let's have a look at question 2 then. So question 2 isn't a word problem, it's just some of those missing number problems. And you can see that where the box is, we've got a number missing. So you've got A, B and C. Have a go at answering these questions, finding what number goes in that missing box. remember to think really carefully about what your parts are and what your whole is. Click pause and have a go. Let's talk about these questions then. Let's start with A. So this is what I drew to help me work out A. I knew that something at 82 equals 91. So 91 is my whole that I'm trying to get to. Something, remember this is the missing one, something at 82 equals 91. Now I could see, now I'd drawn it in a part whole model, that one way of working this out would have been to do 91, take away this part, 82, and that would have given me the answer. So 91 take away 82 gives me 9. I might have been able to do this in my head and just think, oh, what can I count on from 82 to get to 91? But either way, the part whole model may have helped you there to think about what was going on in the question. Let's have a look at part B. This is what I drew to help me with part B. Now, this is an unusual calculation, isn't it? Something take away 19 equals 39. So you have to think carefully here about what your parts are and what your whole is, because it's tempting to just see that 39 is the biggest number and put it as your whole. But actually what we're saying here is something, a whole that we don't know, take away 19, one part, gives us another part, which is 39. And as soon as you've drawn this out, you can see that the way to find out this missing part, you can do 19 add 39, and you'll get 58, and that's your missing number. 58 take away 19 equals 39, or 19 and 39 makes 58. Okay, let's have a look at part C. So part C was something, add 5, add 9 equals 23. Now you can see when I draw this out in a part whole model what we're trying to do here. We've got 23 as our whole, 5 and 9 are two of our parts, and we've got one missing part. Now I decided I was going to do this as a subtraction. I thought if I start with 23, take away the 5 part and take away the 9 part, then I'll know what I've got left. But first I wanted to find out what 5 and 9 was altogether. So I did 5 add 9 equals 14, and then I did 23 take away both of those parts, which is 14, and my answer, what I had left, was 9. So the missing number here was 9. 9 add 5 add 9 equals 23. Okay, you've done a brilliant job so far. Let's have a look at the challenge. So the challenge today. James buys a large drink for 50p and a small drink. The small drink costs 20p less than the large drink. How much does James spend in total? Right, there are two parts to this question, so think really carefully, work through step by step, and see if you can use a part whole model to help you. Click pause here and have a go. Okay, let's talk about this question then. So the first thing we need to think about is how much does a small drink cost? We know that it costs 20p less than a large drink, and we know that a large drink costs 50p. So this is the first part whole model I drew. 50p is how much a large drink costs. A small drink costs 20p less, so that means that a small drink costs 30p. So now we know that a small drink is 30p. We know that James buys both a large drink and a small drink, so we need to add the price of a large drink and a small drink. So I drew this part whole model. 50 pence add 30 pence equals 80 pence. So we know that James spends 80 pence in total. So even though the calculations in that sum weren't particularly tricky, by drawing a part whole model, it just helped me keep track of each step. And by writing out some short sentences, I didn't get lost in the question. So well done on having a go at all of those questions today. You might have found some tricky, you might have found some easy, but well done for thinking about how you can use a part whole model to help you understand what's going on. We'll leave things there for now. Well done on finishing another lesson. Brilliant job. I'll see you again for the next one tomorrow.